Gas evolution happens when a reaction creates a product in the gaseous phase. We can see it in a number of chemical reactions, such as that between zinc and hydrochloric acid to make hydrogen gas. But there's an even more spectacular chemical reaction that demonstrates this concept particularly well. The dehydration of sucrose utilizes sulfuric acid as a way to separate water molecules from the sugar molecule, creating water in the gaseous phase as well as a black carbon column. This also creates sulfur dioxide gas, which is noxious, so we'll be using a fume hood. As you watch the reaction progress, make sure to look for black fluid being produced, as well as steam on the sides of the container. For trial 1, we'll use 12.5 molar sulfuric acid. We begin by adding a small amount of water to the sucrose in the container to let it dissolve. For the concentration of sulfuric acid that we'll be using, it's important to complete this step to eliminate the time delay that usually happens at the beginning of the reaction. We keep adding water until we develop a thick paste of sugar. Next, we add the acid. At high concentrations, sulfuric acid is very viscous, so we must take extra care to eliminate any drops that may be found on the side of the graduated cylinder. Swirling the mixture allows the two chemicals to mix easily, increasing the rate of the reaction. And nothing. After half an hour, all we have is a thin layer of carbon. The problem is that our sulfuric acid isn't concentrated enough, even though it's 12.5 molar. In other words, instead of this, we need to make our beaker look like this. It's time to upgrade our materials. For the next trial, we'll use lab-grade sugar and some seriously strong acid. The reaction is extremely exothermic, and you can see that I accidentally melted the cup the first time I tried it. Although both sulfur dioxide and steam are colorless, you can clearly see them escaping the reaction as it progresses, thus proving that this is a gas evolution reaction.